On OneNote, you've got your outline, which you need to make sure that you are looking at, you're reading. I've got a rough doodad over there about what work we're going to be doing through the bookwork, but we're starting with the worksheet from moi. This looks crazy, but you'll see it's there. So anyway, in your time, you can have a look. This is meant to be a 6-week topic, and within this, you're going to have your investigation. Okay, think about it. This is now week 4. We want to try and move swiftly so that we can get our test done by week 10. So you don't have to carry it over onto the holidays, because you'll probably be just tweaking your investigation over the holidays. We're not going to make the investigation bigger than Ben-Hur. Short, sharp, shiny. Nice algebra. This calculus, you might have heard, but that's pretty much 2/3 of year 12. Okay? And it's fantastic. It'll fix up any algebra stuff that you might be shonky with. So awesome, awesome, awesome. So that leads to, what is calculus? And there's a whole lot of stuff that you can read in your textbook if you really want to, but to sum it up, it gives you the rate of change at a particular point, okay? Or the slope, right? Because that is what we talk about, the rate of change, how the rise moves over the run. That's a rate. Would you agree? So if you've got someone, you know, a distance graph and it's really steep, you know that their speed, that's a rate, is quite quick. The steeper it is, the faster it is, and so on and so forth. And this hasn't been a problem for us thus far. Would you agree? We've been able to find the slope easily. 2 points. Y1 take Y2, or Y2 take Y1. Yeah. Rise over run. Find the slope. Sweet. If it's going this way, we know that the slope is positive. If it goes the other way, it's decreasing, and therefore we know it is negative. The steeper the slope, the bigger the value. Still happy? So what is the problem? Why is this calculus such a big deal? Right. So Brodie just said, oops, my finger's not working here. The deal with calculus is that we don't have 2 points, because what we want to do is we want to find the slope at a particular point. And so how can we now use our slope formula? Because we don't have 2 points. We only have 1. So we haven't got a Y2. Does that make sense? So how are we going to go about doing that? And as you can see, as we move along at every point, so at C, what would we say our slope is at C? Give a rough estimate. Positive or negative? It's negative. And would you say that's a bigger value than at D? Anyone want to know what the slope is at the origin? 0, well done. Horizontal line has slope 0. Very good, very good. And of course, positive, positive. If A and D, they were like level there, anything you want to say about their slopes? I know what you mean. Would they be? I don't think that would be the negative reciprocal. They would actually be the same magnitude, but one would be positive and one would be negative. All right, so if that one's like 2, then we'd expect that one to be negative 2. I'm sorry, at home you can't see because I'm using my pen. So there at A, that would be 2 positive, and this one would be negative 2. This is on your OneNote, by the way, if you wanted it. So we're talking about give an estimate, but we've sort of gone through that. The green one, negative, would be a bigger number than D. All good, all good, all good. Okay, so this is our dilemma, is we want to find the slope at this particular point. So before we get to the good stuff with calculus, right, there's all these shortcuts that you can do, and you can do it in a blink of an eye. We're going to show you, or you're going to prove these rules that you're going to use. And even in year 12, they will ask you, show it using this long method first, then you can go and do the shortcut. And guess what? They ask you to do that in year 11 as well. Was I not recording any of that? So sorry, I don't know if I just recorded and I double hit pause or what, but basically we're trying to fill out this table that we are moving from this point here. We're going to start off at 4 units, so 1 unit away, so 4. And so we can find our point at 4 when y is 4, 4 squared, when x is 4, 4 squared gives you the y value of 16, and we're going to find our slope. Then we're going to go ahead and do it when we're only half unit away, then 0.1 unit away. So we're getting closer and closer and closer. We're going to see what happens to the slope. So just keep in mind, people, what is our goal? The goal is we're trying to find the slope at 3. Okay, and then if we go, if we're just like 0.001 units away, won't that be pretty much give us the slope at 3? We're only a little bit away. So fill that out. Shouldn't take too long. I will do it too. Yep. So we're just saying here, your y value is 3.5 squared because this is for the function y equals x squared. So when x is 3.5, we pop it in. So now your slope, y2, take y1, and then it's x2. So that'll be 3.5, take 3. Happy? You probably don't even have to write all of the ones in. You might get the gist and go, oh, I'm just going to go jump straight down to. So when it was 3 and 9, what was the last one? 0.001. Okay, that's going to be 3.001, 3.001 squared. And so we'll go 3.001 squared minus 9 all over 3.001 take 3. What's your slope going to be? So fill it out. What is happening? What did we get for this one? 7. Right? And then what did you get for the 3.5? 6.5. And you go, oh, well, that's not exactly the same. And you kept on going, going, going. And then you get down to one of the last ones. What did we get? Ooh, 6.001. If I went 3.0001, I think I put an extra 0 away. So you're just like a smidgen away. What do you think the slope is approaching? Right, it is approaching, right? It's reaching this limit of 6. Correct? So how do we actually deal with all of that? Well, good old mathematicians come up with, right? We're not going to repeat the process because it's just going to be cray, cray, cray. So what we're saying is we know that the slope of the chord, and is everyone happy with that language, chord? Specky people should be. It's just going from, oh, that's not a chord. The pink is not a chord. What would we call the pink? It's a tangent, something that's just glancing. When it goes, there you go, this one here, C to D, that is a chord, okay? So when we're taking 2 points on the curve, sorry, say that again. So if we've got, like, the best way to explain it is if you've got a circle, oh, that's pretty good, freestyle. Okay, so a chord from one side to the other, chord. If we've got a function from one point to another, that is a chord, but a tangent, not as good. Tangent just touches, just glances. Just, oh, that's a bit bad, but it should just touch, okay, is a tangent. So, back to, so we're happy that this is the slope from one point to the other. It's just saying that's fancy y, take the other y at a certain value of x, and so on and so forth. So now what we're going to do is we're going to move this value of a that we had, instead of being 1 unit away, we're going to get closer and closer and closer. So we want this value of a to be really, really close, or our x value to be really, really close to the value that we want. Does that make sense? So that's why we introduced this limit value. And so this is one of the formulas that we're going to be dealing with to find the slope at a particular point. And we have to have a game plan going on here. So what we're going to do is eventually we actually want to make x equal this value, right? So if we have a look here, we've got y equals x squared. Sorry, people at home, I have to use my pen as you don't know what I'm pointing at. Y equals x squared. We want to find the slope at 3. Now, we know it's 6. How can we prove that it is 6? So, here's our formula, which is just your slope. So, our function, which was x squared, we happy with that? Take away, what does f of a mean? It's saying, what is the y value at the point that we're looking at? So, what's y when x is 3? That's how we use the notation f of 3. Happy with that? And we pop 3 back in. 3 squared is 9. That's how we get this. Downstairs, it's your difference of your x value. And again, we're going to go, it's x take the value that we want, 3. So far, so good? Your goal is you want to replace x with 3. Yeah? Because you want it at that point. Can I do it now? What would happen if I replace x with 3 right now? I have a 0 down the bottom on the denominator. Can I have that? No, it's going to be undefined. So your goal is you want to eventually replace x with 3. But before you do that, you have to cancel out this x take 3 from the bottom. And to do that, it means you're going to have a factor of x take 3 on the top line. As soon as you have that, cancel, slap in x is 3. So let's have a look. We recognize x squared take 9 is, hello, difference of 2 squares. So we're using our quadratic skills from previously. We factorize, and now can you see x take 3, take x take 3, they cancel out? Okay, notice, do you have to keep writing the limit, the limit, the limit? Yes. Right? Why have I stopped writing the limit here? Because I'm actually now replacing x with 3. I can do it, can't I? 3 plus 3, oh my God, it's 6. We have to do it like this for a little while. And then you'll be able to say that, hey, the slope is 6 in one line. But we have to appreciate it first. Okay? So, our turn to actually try. So this is on your sheet. It's on day map. What's it called? OneNote. We are now going to do one ourselves. So, lovely little heading, calculus, first principles. Can you make sure that you have this formula? Without ruining the surprise, we are going to have a second formula for this, because what happens if I change my mind and I go, do you know what, Dan, I've changed my mind, sorry mate, but I don't want the slope at the point 3, I now want it at 5. Does that mean you have to do this all over again? Well, if we don't have the second formula, yes you will. So the second formula will give us, a slope function. But we have to know how to do both ways, okay? So we're doing this one first. When we have a point, then we'll do it when we don't get given the point. We love it, we're happening. So, fine, first principles. Now, I've said the slope, that could mean the rate of change, right? Same terminology. And we want this at the point when x is 1. So because you've got the point, the first thing we're going to do is say, well, f dashed of a equals limit. We're just copying that formula that we had on the board. I'm just pre-drawing my limits. You don't have to do the pre-draw the limits yet. Some students in their books will go dash, 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 you know, just because that's okay. It's your book work. Do not do dash, 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 dash in a test. That will not be accepted. Okay, so here we go. This is just reading the rule. It is telling you what to do as long as you can read your notation. So what is our f of x? 2x squared, right? F of x equals 2x squared. So we go 2x squared minus, right, this is the f of 1 all over x take a. Oh, no a, because it should be 1, because I wasn't listening, right? Getting excited. I was a bit excited, friends. Why is it f of 1? Yeah. Because my a, right, my a is the 1. That's the point that we want, yes, because we want it at x equals 1, so that's the point that we're after. I know that's confusing, but because we want the slope at x equals 1, that becomes our a value because this f of x just stays as our function. So your a is the value for x that you want the slope at. So next bit, good question though, we've got 2x squared minus, what is f of 1? How do we find that? You will put 1 back into your function. So I don't think you would have to write this down, but I'm just writing it in case people can't follow. So it's 2 times 1 squared, which all day, every day is 2. It always helps to know your game plan. What is our plan? What do we want? We want to substitute, we want to replace x with 1. But we can't do it too soon because you'd end up with 1 take 1, 0 at the bottom. So you cannot do it yet. So what you have to be able to do is find a common factor of x take 1 on the top line. So we look at the top line and we go, ooh, what do we do? What do we do? Ask ourselves that all-important question. Is there a common factor? Is there one? Yeah, baby. So we pull out the 2. X squared take 1. Oh, we're starting to get a little bit excited because when we see x squared take 1, we go, oh my God, I recognize you. What are you? Difference of 2 squares. Did you invite difference of 2 squares to the party? No. Limit x tends to 1. X take 1. X plus 1. And so now this requires a colour change. Cancel. Cancel. And I'll just pause there for a moment so you can digest. A lesson for this moment. Cancel, cancel. Now we sub. What do you think we sub? X equals 1. So we end up with, I'm actually going to make a big deal about this. We can now say, therefore, I know, it's big, Therefore, f dashed of 1, so this is saying, that's notation, the slope, this is the derivative, the slope, the rate of change when x is 1 is going to be 2, and I know you all know 1 plus 1 is 2, but I'm just making a point of it. You don't have to, just in case you're looking back. So we know 2 times 2, it's 4. Huzzah. B now. We want to find the slope of this function at x equals 2. And just to make me happy, do we know what that function looks like without having to look at our calculator? F of x equals 3 minus x squared. It is definitely concave, right? So think back to our original, the original and the best, that one there is y equals x squared. So when I then flip it with the minus, that makes it go downstairs, doesn't it? And what does this plus 3 do? Moves it up. Now, Hames went left or right. What makes it move left or right? When it's in the bracket. So if it was like x take 3 squared, that's going to move it 3 to the right. But in our case, it's not that. It's positive 3 there. So it's gone up. So I reckon it looks a little bit like this. And we're wanting the slope at x equals 2. So maybe somewhere around here. So what are we expecting our answer to be? A negative answer. So it's nice to have an idea. Again, not to get you too excited, but your calculator will not only be able to give you the slope in an instant, it will actually draw the tangent for you and give you the equation of the tangent. Wow! $250 worth is coming up. All right, so here we go. F dashed of what? 2. That's our A value. I know Lorenz doesn't like this because it says x equals, but for us, that is, at what value are you wanting the slope? That's your a. And we're saying we want it at 2, so therefore a equals 2.
Yeah.
You okay with that?
Yeah.
Excellent. So f of 2, f dashed of 2, which that, so f dashed of 2, the dashed represents that you are, it's the slope, it's the derivative. And there's going to be 2 symbols for it. Well, this is the first one. Okay, we go limit. Because the limit is we're moving. Remember, we're taking a point a little bit away, and then we're coming closer and closer and closer to our value of 2. Okay, so limit, as x is getting closer and closer to 2, what's happening to our slope? So we've got f of x, so what's our f of x? 3 take x squared. Like, I've been a little bit slack and I've copied my formula. I would imagine you should write your formula and just doing underneath. Okay, what do we have to do now? Minus f of 2. I have to be very careful and say f of, not f off. I know. People might get the wrong idea. We go limit. Now, can you see what would you put as your next line? If you want to put everything in there, you can. If you want to work it out to the side and then put it in, that's okay. Board's having a little bit of a conniption, getting a bit excited as well with calculus. Okay, what am I going to write now? Well done, right? It's +1 because you're saying minus, right? Following the formula, minus 1, which actually becomes a plus. Probably the most mistakes that students make is they don't want to write this limit and another line again, and then they stuff up. So keep writing, and then it looks like you've done heaps of work, but really you're just rewriting stuff. Okay, that's a +1, so 3 plus 1 gives you 4 minus x squared. So we've done all that we can do so far, and now we're down to, what is it that we want? What do we want? When do we want it? Now, we want to replace x with 2. But in order to do that, you have to cancel out that x take 2 from the denominator. We getting this? To do that, you have to factorize the top line. Now, if you go straight into, like, you can recognize this is Lorenz's mate, difference of 2 squares. If you factorize it as is, you're going to have 2 take x, 2 plus x. Is that close enough? No, that is not the same. So how do we make it so? Do you agree, if I pull out the minus, this is the same as this? -1 times x squared is negative x squared, and what's a negative times a negative? +4. We happy with that? Yeah. And now, can we factorize x squared take 4? What does x squared take 4 factorize to be? Yep. Huzzah! X take 2, x plus 2. Now I know that I have done this right because I've got my factor that was on the denominator. If I didn't get that factor, I wasn't able to, I've done something amok. Maybe I've missed a negative somewhere up there. Like if you had actually made that instead of take, instead of being take 1, if you had just made that take 1, you wouldn't have been able to factorize it properly. So then go back up, look for your error. Make sense? Okay, best bit now is that because we have cancelled out the x take 2, we can now sub. So therefore, f dashed of 2, replace it in 2 plus 2 gives you 4. The negative is out the front. Did that match up with what we expected? a negative slope. Woo-woo. The next one, I would say you should be able to tell me right now what the slope is at x equals minus 3 for C. In fact, you should be able to tell me what the slope for C, what the function is at x equals 10. You should be able to tell me what the slope is for that function, Dan, come on, at x equals minus 100. Not 7. What is this function? It's a straight line. Walking in a straight line. What is the slope of that function at any point? Y equals mx plus c. What is the slope at any point? M. So you already know that for this function, you know your answer should be 5. So what I'm asking you to do is, using that process that we've got, prove it. Go forth.